Video is just describing or working through problem 2.32 in, this was part of GP4. So the problem here, it sets up a sort of a scenario here. So it says, how old are women when they have their first child? So they have a distribution here of the age of the mother for all firstborn children in the United States for the year of 2012. So you can see here they have buckets, and it looks like they're going in 5-year increments. They've eliminated anyone under the age of 10 and over the age of 50 because the number of firstborn children for those age brackets is, as you would suspect, incredibly low and negligible for this study that they've done. So the first part of this question asks, part A asks, for comparison with other years and with other countries, we prefer a histogram of the percents of each age class rather than the counts. Why? So they want to know, why is this the case? And I'm not going to actually put this in writing in here, but the reason is because if we're dealing with counts, even if we're looking at a different year, but I think this is especially true when you're looking at another country, is these counts can be significantly different, in some cases double or triple or half or less than half of what the counts are here. So the reason why it's better to use the percent is because that's a relative number, and it's relative to the age bracket, and therefore it can kind of give you a better, so no matter what the counts are, the relative percentage is always going to kind of be the same. So you would think anyway. So that's the reason why we do it that way. So part B asks, how many babies were there? So to get that, I've actually set up a little section here just to get the total count of all the babies. And really all that is the sum of all of these numbers here. And of course, we're not counting the negligible ones under the age of 10 and over the age of 50. But to do this, we can just use a formula. So sum equals, and then I can select this data and I can get my count. So the total babies born here is 1,570,809 babies. So now, if I want to get the percent, because the next part of this question is actually saying use percents to do your histogram. So it wants to see what is the distribution, and it wants to see what the distribution is if you use percents as opposed to just the counts, right? Because getting back to part 1 or part A, it kind of makes sense to use percents here. So to get the percent, it's actually really quite simple. I can just say equals, and now I know that my count here is in column I, and I'm going to put this in parentheses. So column I, row 2, and I know that my total babies is in column I, row 11, which is right down here. Now if I select it, it's actually going to, it does the right thing here. Sometimes it puts in its own little language, so sometimes I like to hand type it. But the one thing that we do want to do here is I11 is going to stay the same no matter which age bracket we compute the percent for. So we want to use those dollar signs to make sure that we keep that the same every time. Whoops. And then we want to close out our parentheses, and then we want to multiply it by 100 because we actually want to get the percents. Now, the other way we could do this is we could actually make that percent column of type percent. And so we'll do that instead, just to kind of keep things clean. So I divide those numbers, and you can see here for this one I get 0, but it's actually probably more than 0. If I expand it, it's more than 0, but it's a small enough amount where it's, we're just using whole numbers here. So so now I'm going to get my cursor to be a solid crossbar. I'm going to click and I'm going to drag. Now it should have, it should have filled this. So let me see why it's not filling it. So I3 is here, divided by I11. Okay, so we just need to make this a percent, I think. They're just really small numbers. So I can select all of this data, and I can come up here and click the percent sign. There it is. So the reason why it was all showing zeros was because A percent, if you write it as a decimal, is 100 divided by these numbers, and so they were small enough where it was just rounding to 0, because if you can see here, even the double-digit numbers started with a number less than 5, so that's why that happened. So here are our percentages here, and you can almost see just by looking at what the shape of this histogram is going to be. But let's go ahead and make our histogram. So I'm going to select the data. So I'm going to select the age brackets, and then I'm going to click Control. Whoop, the wrong control. I'm on a Mac, so if you're on a Mac, it gets a little tricky, but I'm going to select my data, and I'm going to hit Command and select the percent column here. Now I could do it to count to, and we can do it both ways in this video. I'm going to do Insert, and then I'm going to go here to the statistical charts, and I don't want to pick a Pareto. I want to pick this histogram here. So I'm going to choose the histogram. You can see it very much does not seem to really reflect what it is we're trying to show here. So let's take a look at exactly why. So let's click on the data point here. Let's go to the Data tab in our formatting section, and we can see that the bins are set to auto. So the trick here is to set your bin to category. And when you set it to category, what it does is it looks for sort of the text version, or the column with text in it, as opposed to the column with numbers, and it assumes that's the category that you want to look at. So here it's done a really nice job. It just kind of formats everything, and there it is. So here's our diagram, or our chart here. Now, just for the sake of comparison, what I want to do is just show you the difference between the two charts. And really, you won't really see a difference, but just so you know that you can do it either way. It's just using the percents actually just makes more sense when you're comparing across different demographics. So here I'll just select the counts instead. I'll say insert histogram. And again, I'll do the same thing. I'll select my data, go to my data tab over here, and choose by category. And you can see here that the one big difference between these two, and I'll just kind of put them next to each other here. The big difference here is you can see on the y-axis here, this is actual counts here versus percentages. And that's really the only difference. So you can see that the histogram is very similar, if not almost identical, across both of these different types. So just so that you know, there's two different ways to do this. So the next question, I'm just going to move these out of the way here. The next part of the question says, well, what are the locations of the median and quartiles in the ordered list of all maternal ages? In which age classes do the median quartiles fall? So the way we want to do this, or the way we want to kind of conquer this problem, is we want to get sort of those descriptive statistics. So I want to get the mean, the median, the mode. I want to get all of it. So I'm going to do the mean just as we always have, say average, and I'm going to use, in this case, the counts. And there's my average, my median, same thing. Whoops, it already had it. My median, I'll do the same thing, and this is across all our age brackets. Mode, not really as important here, because we're talking about kind of a distribution of categories, but an NA means no mode, so I can actually just type in here no mode if I want. Now for the 5-number summary. So here we have a min. We want to get the min. We want to get Q1, so quartile. And we're going to use, remember, the quartile function here. And we're going to select our data, give it the quartile we want, which is 1. And that's our Q1, our median. We can do the calculation over, or we can just point to this number here. Either way is fine. I'm just going to do the calculation over. And then our Q3 is quartile, the data set, comma 3 for the third quarter, and then max is max. So here we have our 5-number summary. Now I can format this a little bit. I can say, all right, well, I want these numbers to, have commas in them, which is always a good thing. Just easier to read, stuff like that. So I can do whatever I want here, but you can see here's our 5-number summary. And now if we look at the median, for example, we can now find the median. So this is 178,950, so roughly 179,000. So if I go to down here, I'll just move it up again, just so it's nearby. And if I look at these numbers, you can see that the median is going to be, and I can maybe even put a line in here. I might be able to just insert a shape, which is of a line. And you can see that the median here was 179, which is roughly, I would say, somewhere around here. And I'm just, I'm just drawing this in. No big deal. I can actually just make this stand out a little bit. Make it red. Whoa, no, that's not exactly what I wanted to do. Sorry. I'll make this line red so it kind of stands out, maybe a little thicker just to, oh, here it is. Make it a little thicker just so that we can see it. So that is our median right there. Now our mean is 196, so a little bit higher. So if I move this, let's say this is 170. Let's say it's around here, actually, just for the sake of argument. And then we'll move this is going to be the mean right here. So it's a little higher. We'll make it a different color. We'll just make that green. So that's our median right there. And now we want to look at the Q1 and Q3. Well, Q1 is at roughly 19,000. So I'll just throw that in. That's probably going to be way down here somewhere. If that's 50, it's probably less than halfway down. So that's our Q1. I'll just make that a slightly different color. And then our Q3 is at 330, roughly. So we'll put that guy up here somewhere. And we'll also make that a different color. Maybe I'll make it yellow, just both of these yellow, just so we know that these are the quartiles here. So those are our quartiles there. So you can kind of see where things are, where things are falling. Now I could also do a box plot of this data. So I could select these counts. I could go to insert. I could choose the statistical stuff, and I could actually do a box plot, which would give me similar results. But it's kind of nice to sort of see it relative to the curve here, and we're going to talk more about those curves in a minute, but in another class, upcoming class. But here you can see, so it says, what are the locations of the quartiles in the ordered list, and in which age classes do the median and quartiles fall? So you can see here that the quartiles really, things fall above the mean in the 15 to 35 range. So anywhere within here, things are falling within the bounds, right? But outside of that, things are falling out. So things are falling out on the 10 to 14 and the 40 to 44. So that's kind of how you want to look at this. And we can also talk about outliers, but I would assume that the outliers would have been less than 10 and more than 50, in which case they just dropped that data altogether. So that's a quick explanation of how to sort of work through one of these types of problems here.